Hello friends, welcome to ninth session on numerical analysis of BSc 5th semester. In this session, I would like to explain you about one of the most important numerical method for solving the non-linear algebraic equation or non-linear transcendental equation. So let us start the discussion. So the method is known as bisection method. The title of the method which we are going to use to solve the non-linear equations is bisection method. And what are the things we have discussed in the previous session? Let me recall you. In the previous session, we have understood what are the non-linear equations, what are the transcendental equations, and what are the different numerical techniques of solving such non-linear equations. That we have discussed in a very detailed manner in the previous session. From this session, we will be able to understand what are the steps involved in the bisection method. That is the first numerical method to solve the nonlinear equations, and we will be studying in this particular session that what are the steps involved in this method, and we will be using the same method to solve couple of given nonlinear equations. So that will be the objective of this session. So let us begin with the method. Now I would like to demonstrate what is the method behind this. For example, the given equation, the nonlinear equation is of the form f of x equal to 0. So first what we have to do, we have to write the given equation in the form of f of x equal to 0. That is, we have to take all the non-zero terms, all the terms to the left hand side, so that on the right hand side it remains only 0. So that is the first adjustment we have to do. Then we have to see two values a and b. These are the two real numbers a and b in such a way that f of a and f of b. What we have to do, we have to search for such two numbers if they are not given. In some of the questions, a and b will be given. In some cases, these two values may not be given. If these two values are not given, then what we have to do, we have to search for such numbers by trial and error. That is, we have to start with 0, we have to go for 1, 2, 3, or -1, -2, -3, like that. We have to choose by trial and error, and we have to observe, and in each case f of a, what is the value of f of a and what is the value of f of b. We have to see that f of a and f of b are of opposite signs. This is very important. When f of a and f of b are of opposite signs, the meaning is that their product is negative. Their product is less than 0. So this condition, if we observe to be valid, then we say that the desired root exists in between these two numbers a and b. This is most important conclusion we have to make. When we find a and b, two numbers a and b, in such a way that the value of f at those 2 points a and b is having the opposite sign, that is f of a and f of b are of opposite signs, that is f of a into f of b is negative, then we say that there exists a real root of the given equation. What is the given equation? F of x equal to 0. This is the given equation. There exists a real root of the given equation between a and b. This is very important. We say that the root is existing between a and b. That is the most important. And here we say that the root is existing in the interval a and b. So this is the most important first step we have to perform in this method. If the interval is given, there is no need to do this thing. If the interval is not given, then we have to search for such two numbers by looking at this condition, and we have to say that the real root of the given equation, this thing exists in this interval a comma b, that is in between the two values a and b. I hope you understand the first step. Now let us go for the second step. What is to be done? After finding a and b in which the root is existing, we have to bisect this interval. What we have said? We have said that this is the interval in which the desired root is existing. We have to bisect the interval. What is the bisection formula? Bisection formula is a plus b divided by 2, just like the midpoint formula which we have studied in PUC first year. So first point plus the last point divided by 2. That is, we have to take the average of those two. So using this formula, we get the bisection of the interval a comma b in which the desired root exists. So this value, what we get as the midpoint, that is by using the bisection formula, that value is to be taken as x1, and this x1 is the first approximation to the desired root. We say that this x1 is the first approximation to the desired root. Try to understand. Earlier there were a and b. Between a and b we said that there exists a root by looking at the condition f of a into f of b less than 0. After concluding that a and b are two such values, in between them the root is existing, we have bisected this interval and got, by using this formula, this is the bisection formula, by using this simple formula we obtain another point, that is the midpoint between a and b, and we are saying that this point, this new value x1 is the first approximation to the desired root. We will not stop at this point. We will proceed further because these are the iterative type of methods. I have explained very well about the iterative type of methods in the previous session. Now what we do? We will find out f of x1. That is, what is the given equation? Given equation is f of x equal to 0. In the LHS, whatever thing is there, that we take it as f of x. In that f of x, wherever x is there, put the value so obtained, that is x1. You will get f of x1. So f of x1, when you evaluate, you have to observe the sign of f of x1. You have to see whether f of x1 is positive or negative. That is the sign of f of x1 you have to observe. Depending upon the sign of f of x1, you have to make a conclusion. So what is that? If f of a and f of b are of opposite signs, f of a and f of x1 are of opposite signs. Try to understand. Here what is going to happen, I will show you using a small picture. Try to understand. First, this is a and this is b. We say that we find the value of f at this point a and we find the value of f at this point b. If f of a at this point and f of b, that is the value of f at this point, are of opposite signs, that is their product is less than 0, then we say that the root is in between these 2 points, that is on this line. What we do by using this formula, we bisect. Bisecting means getting a point here. So that point we call it as x1. So we get x1. After getting x1, what we do, once again we find the value of f at this point x1. That we call it as f of x1. After having f of x1, we look at its sign, whether it is positive or negative, we look at that. Then we observe the sign of f of a and f of x1. If they are of opposite sign, that is if f of a into f of x1 is less than 0, that is the sign of f value at this point and f value at this point, if that is opposite, then we say that the desired root exists in between these two. This is an important conclusion. Then we say that the root exists in the interval, the new interval a to x1. You look at this interval. The earlier interval was a to b, now the new interval is shortened. It is made as half. So the new interval is going to be a to x1. In this interval, we say that the root is existing. After that conclusion, once again we use the same formula. Once again we use the same formula. We have to bisect this. We have to bisect this and we have to get the new value in between this. That we call it as the second approximation. This is on one hand. That is if f of a and f of x1 are of opposite sign. We conclude like this. If not, definitely f of x1 and f of b will be of opposite sign. Then we say that the root exists in the interval x1 to b. So if the root exists in between x1 to b, in that case we use the same formula with x1 as a or with a as x1, b as it is, and subdivide the interval. Get the second approximation. So this is the second step. Most important thing you have to observe, after getting x1, find f of x1, look at its sign. If f of a and f of x1 are of opposite sign, use the same formula with b replaced by x1. Then you will get another point here that we call it as x2, that is the second approximation. If the case 1 is valid, that is the value of f at a and value of f at x1, they are of opposite signs. On the other hand, if it is not true, on the other hand, f of x1 and f of b, if they are of opposite sign, then we say that the root exists in between x1 and b. Again go for bisecting the interval x1 to b by using the same formula with a replaced by this new value x1 and get the bisected point here, that is in between x1 and b. There will be a new value by using this formula. That value we call it in that case as again x2. Okay, this will not be the case, this will be the case. So x2 will be the second approximation we will be getting. So I hope you understood. We got x1 in the first approximation, that is in the first iteration. In the second approximation, that is in the second iteration, we get x2 by using the same formula. So this is the iteration method. The same formula, the same method is repeated again and again by using the previously obtained values. So previously obtained value we have used x1, we have used in the formula in place of either a or b, and we have computed the new value x2. And we see that after getting x2, we see that whether x2 and x1, the iterated value, the second iterated value and the first iterated value, whether they are almost same or not. If they are not same, go for subdividing again. You have to go for the next steps again. So what you will do, you please assume that the root is in between a and x1 and the root is the approximated value is x2 by using the bisection formula. So what happens here, this entire portion will be rejected. We will be concentrating only on this portion, and in that case, after finding once again what will we do, after getting x2 we will find out what is f of x2. After finding f of x2, we see the sign of f of x2, whether it is positive or negative, and we see whether the sign of f of a and f of x2 is opposite, that is f of a into f of x2 is negative. If so, we say that the root is in between a and x2, that is once again the interval is shortened. So once again we go for subdividing it. We will call that approximation as x3. Okay, that is x3, f of that is x3. This is one case if the root is in between these two, or else if the root is not here, it will be here. That is if the value of f at x2 and f at x1, they are of opposite sign, then we say that the root is in this portion. If the root is in this portion, we avoid this entire part. We have already deleted this part. We will be deleting this part as well, and we will be concentrating only on this part. So in that way the process goes. Now what we are assuming, the root is in this portion, and by using the same formula we got x3, and in that case we have ignored this part. In the next steps we will not be concentrating on this part, we will be concentrating only on this part. And in this part what we do, we will compute what is f of x3, and we will look at f of sine of f of a and f of x3. If it is opposite, we say that the root exists in between these two. In that case we will ignore this portion, we will concentrate only on this part. Again we subdivide this smaller interval. See what is happening, the interval is being contracted, it goes on decreasing. Earlier it was a to b, then it became a to x1, after that it became a to x2, now it has become a to x3. Again it is to be subdivided by using the same formula and to get the new approximation x4. So now after getting x4, we have to once again check the fourth approximated value x4 and the third approximated value x3 whether they are almost same or not. That is, they are same up to certain fixed number of decimal places. If it is so, we can stop. If not, proceed further in the same way. By making the interval smaller and smaller, you go in search of the desired root of the given equation. So this is how the bisection method proceeds. If you solve the couple of problems, you will definitely get better idea of this. I hope you understood the procedure. Now I request you people to look at the examples. So the first example I am going to consider over here is okay. Let us go for the first example. Yes, this is the first example. Find the positive real root of this equation. Equation given here is x cube minus 3x square plus 1 equal to 0 by using the bisection method. Correct to 3 places of decimal. What is the meaning of this correct to 3 places of decimal? The meaning is that two consecutive values of x, that is x value obtained in, for example, kth iteration, and the x value obtained in its previous iteration, that is k minus 1th iteration, must be same up to 3 decimal places. So that is the thing we have to see whether they are same. Then we say that the solution is correct to 3 places of decimal. So that is the thing we have to look at. Now consider the solution. So first we have to consider the given equation. It is in the form of all the terms. You see they are on left hand side. Remaining term, that is on RHS, is only 0. Nothing will be there on RHS. Everything is on LHS. And whatever is there on LHS, you take it as f of x1. You take it as f of x, that is. So this is most important thing. We have to take it as f of x. After taking it as f of x, we have to find out a and b, that is the interval a comma b, in which the desired positive real root exists. So how it will be done? It will be done by bisection method, as I have told you earlier. So what is to be done for that? Find out the value of, choose 0 and 1. See, I have taken 0 and 1. A is 0, B is 1. Find out the value of f at a, that is f at 0. I got the answer 1 plus 1. You can use this thing and you can get very easily the answer. Wherever x is there, if you put 0, 0, 1, answer is 1. If you put 1 in place of x, you will get f of x1, sorry, f of 1. So f of 1, if you simplify this expression, you will get f of 1 as minus 1. You can observe. Now this is very important observation you have to do. These two values, you see the answer of f at 0 and the answer of f at 1, they are having the opposite sign. One is positive, another one is negative. When these two answers are of opposite sign, you can conclude that the root lies in between these two values, not these two. Don't get confused. the value exists between, the desired root exists between this value and this value. This is most important thing, 0 and 1. So that thing I am writing over here. The desired root lies in between 0 and 1. So therefore take a, the lower value, the smaller value as a, that is a as 0, b as 1. Taking a as 0, b is equal to 1, that is over. So the first thing we have computed, we have computed the interval in which the desired root lies. Now go for the bisection formula. Using the bisection formula, here is the bisection formula, you can observe. This is the bisection formula, a plus b divided by 2. By using this formula, you can get the first approximated value. You substitute the value of a, substitute the value of b divided by 2. It is 1 by 2, that is nothing but half. So the first iterated value, that is x1, is 0.5. You should not stop, proceed further. Find out what is the value of f at newly obtained value x1. So this is f at x1, that is f at 0.5. Use the same expression, this is very important. Use the same expression, I call it as equation number 1. Using the same equation number 1, what is the value of f? Wherever x is there, substitute 0.5 whole cube minus 3 into 0.5 whole square plus 1. Using this expression, if you simplify using your calculator, the answer is going to be 0.375, which is having the positive sign. You have observed, let me once again draw the picture for your sake. See, the value, the first value was, first I have chosen a as 0, b as 1, and I got the value of f at 0 as positive, and the value of f at b as negative, that is. So positive, negative, in between them the root was existing. Therefore, we went for the bisection of the interval and got the value 0.5. That is exactly the midpoint. And this is 0.5 we obtained in this step, in the first approximation. After having this 0.5, we have computed the value at f at 0.5. And the value at f at 0.5 is again positive. So when it is positive, we don't bother about this particular place. This will not be the region of our interest because the root will not exist in this portion. We will simply ignore it off. We will cut it off. We will concentrate on only this portion, that is 0.5 to 1. We say that the root lies in between 0.5 and 1. That is in this portion, 0.5 to 1. So when the root exists between 0.5 and 1, what will we do? We will again use the same bisection formula. It is here, you please see. 0.5 plus 1 divided by 2. This plus this divided by 2. Again you bisect it. You will get the new point. 0.75, that is. 0.75 will be the answer. So now we have bisected the interval. Again, this value will be called as x2, the second approximation. You see, this is x2, and x2, after getting x2, we have to find out what is f of x2. I will show you how it is proceeding. You see, f of x2 we have computed, x2 as 0.5, as I have told you, x2 is 0.5 we have computed, and after getting x2, we see the sign of f of x2. It is minus. So when it is minus, we observed in the previous case that f at 0.5 was positive, and now f at 0.75 is negative. Therefore, f at 0.5 and f at 0.75, they are of opposite signs. When they are of opposite signs, we say that the root exists in between 0.5 and 0.75. That's what I wrote over here. The root lies in between 0.5 and 0.75. When the root lies between these two, we will subdivide that interval 0.5 and 0.75. This plus this divided by 2. Same bisection formula I have used. And I got the answer as 0.62. So now this is x3. So answer is x3 equal to 0.62. But earlier answer was x2 equal to 0.75. They are almost they are most different. Now we have to proceed further. So what we do, we will go for finding f at x3. So f at x3 we got it as positive. F at x2 was negative, f at x3 is now positive. So what is now our conclusion? Our conclusion is the root is in between 0.75 and 0.62. See, 0.62 is positive whereas 0.75 was negative. And therefore we can say that the root lies in between these 2 points. Okay, so 0.62 and 0.75 are the new points in between which the desired root is existing. So now we have to again subdivide the interval. Using the same formula, bisection formula, and we are going to get 0.68 as x4. So go on proceeding like this. You have to proceed in the same way, and ultimately I will simply skip and I will show you at the 11th stage. If you do such type of work by yourself, it is very simple, you can do it. At the 11th iteration, the value of x will be 0.6526, that is 0.652. Okay, this is the value of x obtained at the 11th iteration. Now the value of f at this point we have to find out. So that is again positive. We see that the value of f at this point and the value of f at the previous point, that was 0.653, which was in the previous iteration, they are of opposite signs. We conclude that the root is lying in between these two, that is 0.6523 and 0.653. The root is in between these two. When the root is in between these two, again subdivide the interval. When you subdivide the interval, you will get the new value x12. The 12th approximated value will be 0.652. You can observe the value x12 and x11. That is the two consecutive values of x. They are same up to 3 decimal places. You can observe up to 3 decimal places, these two values are same. Up to 3 places of decimal, 0.652, 0.652. So the two values are same up to the 3 decimal places. We say that the solution is correct to 3 decimal places. Therefore we can stop at this point and we can conclude that the final answer is the one which we obtained in the 12th iteration. In the 12th iteration we got the value as 0.6528. We can say that this is the desired root, or else we can round off the number having only 3 places of decimal. If we round off, this becomes 3, because this is a number greater than 5, this becomes 3. So the final answer is 0.653. So this way the bisection method proceeds. I hope you understood very well the steps involved in the procedure, and you can really do very well with this method, even though it has many steps, but it is very simple. The formula is very simple. Please try to solve your own problems by referring the book. The book is always with you. You please have a look at the book which I have used for my lecture. You please have a look at the book which I suggest you always. So this is the reference book. You can look at this book. Many problems have been solved in this book. You please have a look at them and try to solve. Okay, and this is an assignment question. You please try to solve this question if you have leisure time. Thank you very much.